Hello everyone, my name is Amir. This project uses a machine learning technique called support vector machine to help a doctor classify human cell samples into two categories: benign, and this is not harmful, and malignant, and this is harmful. This classification helps in diagnostic disease like cancer based on characteristic of cell samples. Support vector machine is a powerful machine learning algorithm used for linear or nonlinear classification, regression, and even outlier detection tasks. We are using SVM here to classify cells whether the samples are benign or malignant. First of all, we should import our necessary library, import pandas as BD. This library is useful for creating data frame and we will use it to load our data. Import numpy as NB. Numpy is useful for matrices. Import matplotlib.pyplot as PLT. Matplotlib is useful for visualizing our data. If you want to download the dataset, just go to this repo and download this file. In this repo, you will find all the dataset and the code in this repo. So after that, we will load our data. So we will write pandas.readCSV, the name of our data, cell samples.csv. If you want to see what our data is about, just write data frame, the variable we have stored our data here, .head. It will show you the first 5 rows, the features that we are interested in, and we will use it to classify our data. And this is class. This column has 2 values, 2 or 4. See, the column of class only we have the 2 value, 2 and 4. Number 2 means it is a benign. Number 4 means it is malignant. And as we know that benign is not harmful and malignant is harmful. If we want to see the last row of our data, just write your data frame.tail. It will show you the last 5 rows. If you want to know how many rows and how many columns, just write data frame.shape. It will give you this is the number of row and this is the number of column. And if you want to know what is the number of cells do you have, just write your data frame and dot size. It will give you all the cells you have. All the cells means that all number of rows multiplied by the all number of columns. And data frame dot count, this computes the number of non-null value in each column in the data frame. And if you want to know what values in a specific column and how many values of this column, just write the name of your data frame and the name of your column class dot value count. It will give you 2 and 4, 458, and the number of 4 is 241. What does this mean? If we come back to our dataset, we see a column name class. This column class has 2 values, 2 and 4. As we said before, the 2 it represents the benign and 4 represents the malignant. So we have the number of benign 458 and the number of malignant is 241. The next thing we will talk about is distribution of the classes. We want to graph these values. As we said before, that benign is the class 2 and the malignant is the class. This is the name of our data frame and this is the name of our columns that we will get from our data frame, and we will split the value 2 from our data frame and store it in the benign variable, and we will take only 200 rows. That means after we stored all the value 2, we will take only 200 rows. And the same for malignant. We will get from column class the number 4 and we'll get only 200 rows. And if you want to graph our benign values, just write benign.plot and the kind of your plot will be scatter, and in the x-axis will be clump unique size and the color will be blue and the label is benign. And this is the graph of our benign values. If you want to graph our malignant value, it's the same thing. Just write malignant.plot kind scatter, x clump, y equal unique size, and color equal red, the label equal malignant. And this is our graph that represents the malignant values. If you want to merge our values benign with the malignant value, just write here ex equal ax. For example, ax, and ax is the value of the benign, and you will store it in a variable ax, and just run this cell and run this cell again. I don't know why the graph doesn't appear, but we can write ax here and run again. Here it is the graph. Our malignant and benign are in the same graph. If we want to see all the type of our column, just write your data frame to data type. It will get all the data type of your column. We are dealing with number only, so this column is object. We will convert this column to int because we are dealing with number only. So this part of code to convert this column to an int. If we see data frame to data type again, it will see this column is converted to an int data type. In our data, we don't need this column ID, and we already have used this column class, so we don't need it also. We just want this column. So if you want to know what is the name of all your column in your data frame, just write your data frame dot column. It will show you all the name of the column in your data frame. As we said, we only want this column, so we'll copy this column and store it in another variable. This variable is called feature. We will make from our data frame this column. We have 11 columns. We will get only 9 columns from this 11 columns. After that, we will convert the feature data frame to a numpy array and assign it to x variable. And if you want to see the 5 entries of the array, just write the name of your X variables that you have stored the array here, and 0 to 5. And here it is the array. We have 5 rows. We will convert also class column to a numpy array and store it in the variable y. After that, we will train our model. We have 100 rows. We will divide this number of rows to 80 row for training and 20 rows for test. To train your model, just import the library learning.model selection, import train test split. As we divide the data into training and testing, we write x train, x test, y train, y test, and equal train test split. We will train x. This is the variable we have stored the features, and y, this is the variable we have stored the class. And test size, we have right here 0.2, which equal 20% from our data that we will test, and the rest will be training. Random state, just write any number here. If you want to see what is the number of column and what is the number of row of our X train, just write dot shape. It will give you 546 rows and 9 column, and Y train dot shape will give you 546, and X test dot shape will give you 137 rows and 9 column, and Y test will give you 137 rows. Now we're using the classifier SVM support vector machine. The classifier SVM takes 3 parameters. One parameter is the kernel, 2 parameters, the second parameter is gamma, the third parameter is regularization. We have different type of this kernel. One of them is linear, and we have also polynomial, radial basis function, and sigmoid. The role of this different kernel is to mapping data into higher dimension space. Each of this kernel have its pros and cons and its equation, but there is no easy way for knowing which function performs best with a given dataset, so that we usually choose different function and get the result for each function and compare the results. The next parameter is equal to gamma. Gamma equal auto. Gamma equal 1 over number of features. This is the auto value. And the third parameter is C equal to. This is the regularization. What is the benefit of regularization? We use it to avoid overfitting. And here we are creating an SVM classifier with linear kernels. And here we are training the SVM classifier using the training data X train and Y train. And here we are using the trained classifier to predict the label for X test. And finally we will get our result. To do that, we will import the classification report function from the library sklearn.matrices. And after that, we will print the classification report Y test, Y predict. This prints out the classification report, which includes several matrices such as precision, recall, and support for each class. The report compares the true label Y test with the predicted label Y predict from our classifier. And this is the result that will appear to you. The classification report provides a detailed analysis of how well your model is performing with respect to each class in your test data. Thank you for watching.